Hi everybody, it's Miss Lorenz. I'm going to talk about 3.3 and 3.4 for 8th grade math. And really there's lots of terms here, so I'm going to go through the terms. And then what I'm going to do is pick up a whiteboard and I'm going to do an example problem for you. All right, so first of all, you might want to get these terms down. Linear function will form a graph that is a straight line, and it may or may not pass through the origin. So if you look down here, this is an example of a linear function. It's a straight line, and it doesn't pass through the origin. This one's also linear function, but it does pass through the origin. So linear is kind of a broad term. It essentially means straight line. Proportional relationship is a graph that is in a straight line, but it has to pass through the origin to be considered a proportional relationship. So where this one is a straight line, does not pass through zero, this one does pass through zero, it would be considered not only a linear function, but also a proportional relationship. So a function, this is where kids kind of get confused. A function, you guys, could be a straight line, or it might not be a straight line. And so what you're looking at here in these examples is you're looking at a bunch of functions. Notice that some of them are straight lines and some of them are not. And so this first example, it is a linear function. I'm going to mark the origin, or 0, 0, so you can see this one does not pass through 0. So it is a linear function, but it is not proportional. This one is nonlinear because it's not a straight line, but it is a function. In fact, if we use the vertical line test, where we move from one side of the graph to another, we want to see that the vertical line, my pen in this case, touches only one part of the graph at a time, one part of this curved line at a time. And it does. So that is a nonlinear function. This, we already talked about, is a linear function. It's also considered a proportional relationship because here it is, you can see passing through the origin, or 0, 0. This one is a linear function. It does not pass through 0, 0, but it is still considered a linear function. And this one is nonlinear again. If we do the vertical line test, same thing. We can see that it is a function. It's just a nonlinear function. Lastly, I just want you to notice that this linear function here is negative because the slope is decreasing, and this one is positive because the slope, or the rate of change, is increasing. Okay, so let's do a problem together, you guys. So I am looking at number 4 on page 192. And number 4 on page 192 is asking you to take y equals mx plus b and write a function in this form. This is our point slope, or our slope, point slope form, slope intercept form. And we have to contain the points negative 8.3, comma negative 5.2. So remember, this is our x coordinate and this is our y coordinate. And then we also need a second point. You can't have a line without 2 points. So in order to do this, we have to remember a couple things. We have to remember that m is our slope, or our rate of change, and that b is our y-intercept. Okay, so let's start with the slope. Remember, to find the slope, we want to find the rise over the run. Remember, the rise is the vertical distance, or the distance we get when we take y2 minus y1, and then we divide that by the run, which is our x2 minus x1. Okay, so let's go ahead and plug our numbers in. Our y2 is our 9.5, and we're going to subtract our y1, these are our y coordinates, which is negative 5.2. And as you can see here, we have a negative, or excuse me, subtracting a negative. And subtracting a negative is just like adding. So really, essentially, what I'm doing is adding. And here I get 14.7. Now I'm going to find the run. This is my x2 over my x1. Here's my x2, 6.4. And that's because this is my x coordinate. And then I'm going to subtract my x1, my other x coordinate, And again, I have a situation where I'm subtracting a negative, which is just like adding. And so I'm going to go ahead and add those and check that out. I get 14 and 7/10 over 14 and 7/10, which I know is equal to 1. So I know my m right here, my slope, is 1. That's my rate of change, or my y rise over run. Now to figure out what my y-intercept is, what I'm going to do is use one of these points. Remember, this is the directions for one point, or the coordinate pair for one point, or I'm going to use this one. I think I'm going to use this one just because I want to avoid the negatives, but you could use either one. And so what I'm going to do is I'm going to write the equation y equals mx plus b, but I'm going to put in information that I already know. So I know my m is 1, so I'm going to put a 1 in for m. I am going to use this pair of points, so I'm going to put in 6.4 for x. I don't know the b, the y-intercept, that's what I'm trying to find, so I'm going to leave that as plus b. And my y is right here, my 9.5, because that is the y-coordinate that goes with this x-coordinate. 1 times 6.4 is 6.4, so I have 6.4 plus b equals 9.5. And maybe you can see where this is going. I'm going to go ahead and erase this so I have room. So I'm going to subtract a 6.4 from both sides, and now I'm left with 3 1/10 equals b. So now I know my b, now I know my m, and I can plug that in to my slope-intercept form, or my y equals mx plus b form. So y equals 1x plus 3.1. I don't have to have that 1 there. The 1 is optional. If the coefficient is 1, you can have it in there or not. So I'm going to rewrite it as y equals x plus 3.1. Okay, I hope that helps. And you can now get to work on the problems for 3.3 and 3.4. Thanks for listening.